Yeah, hi, good evening, everyone. I am Atul.
Good evening,
So,
sir.
yeah, this is week 8 is going on. Any query from week 8, any specific query? Or I have seen on the course page, so this time actually we released some programming assignments for week 6 and week 7 2 weeks on the work week. So, any specific query from the week 8? Anyone?
So from which week?
Week 8.
No, sir. We get. I
Because
haven't.
week 7 was there was no content, so week 7 was just a that assignments only. So some practice programming assignments will be discussed in the tomorrow session. If it is not discussed yet from the week 7. So otherwise, I have a plan to discuss some experiment on that physical board. So that is sensor related. I have one sensor and how we can get the data from sensor and how we can use that. So is it fine, or if you have any specific doubt, you can ask from week 8. Shall I go with this demonstration?
Sir, I would ask in the means I doesn't understand the question of week sixth grade assignment. Today's deadline. So can you please guide me? Means understanding the question.
Week 6, that graded assignment you are talking about. Okay.
GRPA.
Programming assignment.
Yeah, programming assignment.
Okay. So let me check. One second.
Last question. Question number.
You are talking about this?
Yes, sir.
This one.
Yeah, RGB LED color delay.
Okay, so this programming assignment you are talking about. So
Yes, sir. Even I have doubt in this
RG,
section.
okay, so RGB LED color and delay changing using interrupts. Okay, credit. So what we the interface.
Can you explain the readme.md5 means? It is given when the button is pressed and released. So after complete press and release, we have to change the interrupt or just by pressing.
No, shift the only the press button. Okay, so
Okay,
that is
so
just a
once we
small
have
interrupt,
pressed,
not just a completing the continuously. Okay, so one time just press button and leave it. So that is one
then after
actual event.
means of 5 second or 6 second we release the means just by pressing that interrupt should
Okay, let
call.
me read the question statement once. So RGB functional requirement, design the increment is digital. Okay, RGB color post button. Another thing going to digital 26 and connected to S. Okay, so link with the specific color and duration. The initial color. Button triggered color change. So the should cycle through predefined color. This is color should be changed each time the valid button is pressed and released. So this is simple, just like a microsecond. Just press the button and leave it. Okay, there is no time duration. You can assume here. Okay, so this is just like a event when that signal will become high. So that is means that is one event actually will generate button trigger. So
Okay, sir. Now,
this is the first option. Okay, so this is the one type of button trigger. Second button trigger duration change. If you press the button for some duration like this, okay. So based on that
when the button is pressed,
event,
the delay or the color should change, not just by pressing.
So
It
no,
it shouldn't wait for leaving.
if you just press the button and leave it quickly, so then this second number event should be triggered. And third option, if you just press the button and press it for like this 1000 millisecond, 1 second, okay, and 0.8 second, 0.6 second, that duration based.
No, no,
Okay.
sir. This is the delay. By just
Ha.
pressing, we have to set the delay. 1,000 means 1 millisecond, 1 second, 0.8 second, 0.6 second.
This is the delay for the pressing the button. Let me check. The duration button should cycle through predefined duration. The duration should change each time the button is pressed and released. The current duration should be printed to the serial monitor in the format. Okay, and the color should change each time the button is pressed and released. So I have to check this with Levin. So I think Levin is worked on that. Just give me a minute. Let me check if Levin is free. So I think that he can clear this question. Okay, just give me a minute. Yeah, Levin is joining. So in maybe in 1 2 minute. Okay, so that he will clear that statement. Like confusion for me also for this. So your doubt is only in this point two and point three, correct?
So the when the button means the LED should change something when the color also the duration or color we have to press the button and then release. After release, the duration, the blink duration or the color should change, or it is changed by just pressing and after by just pressing now.
Actually, looks like color will change.
Uh,
Duration will. Levin join. Na? Okay, yeah, Levin. Yeah, go ahead.
yeah, so it can be like after one press and release, it should trigger change. So it can be when it got pressed or when it got released. After one click and pressed, like press and release, it should be change the color.
Uh,
So like so in that question, then you can do it with interrupts, right?
yeah, sir.
So
I
you can set.
have
Sorry.
means we have to press and to wait for the release means we have to press and
Like you
hold for
can
some
have the interrupt when it button is being pressed or the button is being released, right? You
release.
can set
Okay, so
the
in both
trigger to
cases.
be, yeah, anything you can do, either one, right?
Okay.
It is not like in only in the forward or the backward or the press or the release. Can be anything. But the thing
Okay.
is, once the button is pressed and then released, it should change the color.
Then,
In
okay.
anywhere it can change.
Okay. It when can when while pressing or while releasing, but it
Yeah,
should change. Okay. Okay. And in the question number three as well. Yeah, temperature LED bar. It is given that when the temperature is minus 24 degrees Celsius, no LED should glow. So just slightly means it's about minus 23.5, then one LED should glow or it should
no, it's
means
totally off. Minus 20 all the LEDs are off. So you have to map 0 to the number of LEDs in the bar graph to minus 24 to 80.
okay, okay.
Any other doubt in any programming assignment? Any query?
As such, no query, sir.
Okay, okay, fine. Yeah, Levin. So thanks.
Yeah,
Okay. Okay, so I have one experiment that with the help of this real physical board, and that is actually based on ultrasonic distance sensor basically. Okay, so we can detect the object and based on that we can perform some task. So for that, let me join through the other ID that is here in the camera. Okay, just give me a minute. Hello. Hello.
Yes, sir, the screen is visible. Sir, can you turn on the auto rotate mode?
Yeah, the time to end this. This is okay. So, okay. So, I have this hardware. I have already discussed it in the previous session also. Okay, so this is basically that Nucleo board. Okay, so Nucleo board G47RE. So this is the board configuration, and this is one ultrasonic that sensor. Okay, this is name is HCSR04. This is the model name. So this is actually detect the distance object. Okay, so this is one session we have, the sensor we have, and we have this basic jumper wire and one LED and one motherboard. Oh, sorry, breadboard. So these are the hardware we require for this experiment, and after that we will discuss the codes and everything for this experiment, and we will detect the distance, and we will also perform some action based on the distance. So this is the object for this today demonstration on the physical board. So let me open the editor. So we have this STM32 QIDE for this STM board, and so this QID we will use for this, and we will write a exact hardware level code, not the HL or this type of code. We will write a hardware level code for this, and we will directly interact with the registers to perform this task. So we will create one new here project. So you know that how we can create. So file option is coming on the top, and in this option that one new option is coming, and inside the new option STM32 project. So this field we will create. Okay. And inside this we are getting this option. So we have to select the board first. Okay. So this board selector. And in this board selector, we will select our board. So this is the G474RE. Okay, so this is my board. And when we select this, so click on next button. And it asks to give some name for this. So I have already created some previously, so that I am giving new name, ultrasonic uh, detection, and my screen is not visible.
It is visible, sir.
Okay, both the screens are visible now. So that one sensor one and other is code.
Yes, yes, sir, yes, sir.
Okay, okay. Okay, so test like yeah. So here I'll select this empty. Okay, so this empty target projected tile empty. So it will ask to create a totally new fresh project. As a we have to write everything from scratch. Okay, if we select this STM32 cube, Then this will provide some option from the GUI. We can configure the things through the GUI. But here we will write a totally driver based code. So click on the finish. So this new project is created. Inside this, we will click on the source button, and inside this source, and we will click on this main.c. So this is now created. By default, this code is coming. We can remove this. Okay, and this is also not required. Only this part is required. Okay, so in main void these things. So for this, now we need some documentation also. If we are writing some project on our this nucleo board, so we need the documentation also to check our registers value, all these things. So I have already opened this reference manual for our board. So that is one reference manual you can see for STM32 G4 series, and another is just a pin configuration, all these thing details. Okay, so that is user manual. So that provides some board structure and pin configuration or pin mapping, all these things. So these two documents are we required in this setup. And now, so there is one pin. One second, that is one piece for pin mapping. So let me check that. This one. Okay. So this is just a pin mapping based on our STM32 that related to the Arduino board. So because in this board we can connect the Arduino board also. So the pin naming is given on the board, which is reflect to the Arduino pin naming. But we will see corresponding our STM32 pin name. So that will be actually used in our document. Okay, so first thing, we have this sensor. So we will connect the sensor to our breadboard. So that have 4 pin. So the sensor has 4 pin. One is just a VCC for power. Another is ground. Okay, and in between 2 pins are there. So that is one is TRIG, that is for trigger, and another is for echo. So that trigger and echo, so that sensor basically works on the reflection concept. Okay, so that it sends actually a high frequency sound actually, and that sounds just hit any object and reflect back to this. Okay, so that we have to measure that how much time actually takes to travel back. Okay, so this trigger pin actually will send some echo signal or some frequency, and that will be reflect through some object, and this echo point will actually receive the echo signal. Okay, after reflecting. So these 4 pins are there in the sensor. So that sensor we will connect on the board. So we can connect on any side. Okay, so like I have connected this. Okay. After that, we need the pin configuration. So that means at least we will connect basic pins. So that power and ground. So power pin I am connecting through this board, Uno board. So we have this 3.3 voltage. So that is 1, 2, 3, 4, 5. Okay, and that I'll connect through this VCC pin on the sensor. Okay, so that is this. So I have a small wire, so that things have to manage. And this ground wire I'll connect on the ground pin. So that is this ground pin, and here this corner pin. And in between we have 2 pins. So one is for output and another is for input. So TRIG pin we will use as a output pin. So that will send some signal, or we can say that ultrasonic sound, and that sound will be returned back on the echo pin after reflecting. So that we will also connect. So we will use some GPIO pin for that. So we will use that D13 and D12. Okay, so that is two GPIO pin we will use. So I am connecting on the D13 on the board. So 1, 2, 1, 2, 3, 4, 5, 6. So that is D13. I'll show you these pins on the my screen, okay, on the diagram. And this pin we will connect on the trigger. Okay. Another pin D12 we will connect as a echo. So that pin I am connecting on the echo. So this is for sending signal, and after that I'll also connect one additional uh, pin for which is actually D8 or D7. We can connect any pin. So that is for only just a LED. Okay, so the just LED indication. So if any object comes closer, so that we will turn on the LED, and we will pass the ground also. So this is for a power, and we will use one pin for the ground for LED. Okay, and this LED I have, so I'll connect one pin on the positive and one on the negative side. This is the connection we have. So I hope. So I'll show you what I have done is actually. So in this board,
So,
huh?
so for VCC, whether we have to connect to 3.3 volt or 5 volt, so
We can
how we
connect
can.
on any. We can connect on 3.3 as well as the 5. So both actually will be handled.
Okay, so it is okay to connect to any of 5
Yeah,
or
because
3.3.
yeah, we have to check that our LED can handle or not, or if LED is not able to handle, so we have to add the registers. Otherwise, we can directly connect. So this my LED actually can handle both actually 3.3 as well as the 5. Okay. So here actually this in this diagram you can see what I have connected. So from this pin, okay, so this 3.3, and these are the ground pin I have used to connect as a VCC line and ground line. And this side I have connected this D3. Okay, so this D3 as a trigger. Okay, so trigger in the sensor, and this second pin D12 I have connected as a echo. Okay, and this D8 pin I have connected as a output for LED. Okay, and one pin I have taken from this ground, so like this ground for LED. Okay, so these are the connection I have done, and for sensor I have taken one VCC and ground from this side to connect the remaining pin. So one is VCC and another is ground. So this is the like pin structure. So pin 1, 2, 3, 4. In this way, pins are arranged in the sensor. Okay. So I have connected this VCC to directly from this point, and one ground to this like this. Okay. So this is our connection on the board.
Excuse me, sir.
I have done. Yes.
Uh, was it? Have you like so for the output which you are going to take from D8? Was that
For LED.
yeah? So can you change that to D7? Will that work? Or
That
you'll
will
have to
also.
change the wiring. I mean, add a wire there.
No. Actually, I have connect to any pin. So in the code, in our code, actually, I have to change. Okay. So if I connect this 7. Okay.
Okay.
So 7. Then what is happened? Now we have removed this and we have connected this. Okay. So
Yeah.
in our code, we will change accordingly.
Okay. So from in the code from D8 to D7 will make it.
Only
Will change
that
it.
change will be required.
Okay. Okay.
Okay, so this is the pin number actually, but for this D13, D12. Okay, so D13 we are taking for like trigger and for sensor, and D12 we are taking for echo. So this pin we are taking, and D7 we are taking for LED. So D7. But this is the naming for the Uno board, actually that Arduino board. Okay, so corresponding pin we have to identify that what is the port actually, port pin in our STM board. So that here you can see, so D13 is the PA5. Okay, so D13 is a PA5, port A, pin number 5. D12 is a port A and pin number 6. Okay, so this is pin number 6 corresponding. And D7
Actually, sir,
is, yes.
So there is any specific reason for using D13 and D12 as a trigger and echo, or we can use
No,
any
no, you can
GPIO
take
port?
any. You can take any. So actually, I have taken all from the port A. Okay, so all are actually port A, port A, port A. So I have to write some less code to enable the port A that clock
The direction
frequency
that
on.
register was.
Huh?
Okay.
Okay, so I have actually taken all the pins from port A. So I have to enable only the one port actually for the clock frequency. Otherwise, if you take in the another pin like port B, you have to enable the frequency for each like B port and as well as the A port. But this is not the not as the any strict things. You can take any pin which you can use as a GPIO, general purpose input output. Okay, so this is just a random type of selection you can take.
Sir,
Okay.
could you please explain the purpose of all the pins in the above means one page up, sir? Please scroll up, sir.
This pin.
Yes, here trigger, echo, LED, green. What's happening here?
So we have the sensor, ultrasonic sensor. So that sensor takes the power. Okay. So VCC first pin is the VCC and another pin is the fourth pin is the ground. So that is for the power for sensor. And after that, this trigger. Okay. So this trigger pin for the sensor actually we will pass some input. Okay. From our board to this trigger. Okay. So that means this is the output to the actually our sensor from our board, and after getting one signal from the our board, so this will generate a sound actually, okay, ultrasonic sound, and that will be sent through this sensor, okay, at the front. Okay, so you can see the image. So there are two eyes type of things are there in the sensor. Okay, so from one sound, that signal will be sent through this, and that sound signal will be just reflect by some object to the same sensor. So that signal, after reflecting, that signal will be received by this echo pin. Okay, and that echo pin will receive some signal after reflecting that we will pass into our board. Okay, so in this way, we are just giving some signal to the sensor. Sensor is sending some sound, and after reflecting that sound, that is coming to the echo pin, and that signal we will pass to our board on D12 pin. Okay, so this is the sensor working here, and we will calculate the duration of this that pulse, how much time it is taking to sending and then receive. And based on that, we will calculate the distance of the object from this sensor.
Can you explain the overview? Means the overview of how this sensor works. Means
Sir,
So you
please
can.
diagrammatically, sir, please explain, sir, step by step
Okay, okay,
components.
okay. One second.
So we can understand, sir.
I'm opening some.
Block diagram, sir, please.
Actually, I'm just making this type of sensor. One second. So suppose we have this sensor and some like this two eyes type of is connecting. Okay, so four pin are there. So one, two, three, four. So these are just a like a generator type. Okay, a generator and receiver, transmitter or receiver type of things. So here we have this one pin BCC and one is trigger and one is, yeah,
Excuse me, sir.
Vishal. Huh.
Sir, on the official page, that is the census official page, it is explained in a very deep manner. So I have opened it. Do you want me to present it so that everybody can have a look at it, how it works exactly? They have presented
Okay,
it in a
okay. So
very
that,
well manner, good manner.
okay,
So
so you can open, yeah, please, yeah. Yeah, please share your screen. I'll pin.
just a second, sir.
I think in the ES course, some sensor related course is also there. So one second.
Yes, sir. So this is exactly how it starts.
So what is the name of this means sensor, sir? Distance measuring, na?
No,
Ultrasonic.
ultrasonic.
And purpose of this sensor, sir. Purpose.
So
detecting the object.
it is usually used in cars, mainly used in cars, so that while a person is driving or any object is coming nearby the vehicle, so the sensors get activated and it starts to give indication to the driver that a object is nearby the vehicle. It is coming really close to the vehicle.
Okay, very nice, sir. Thank you, sir. Thank you.
Okay. So can you just scroll up? So one that reflection image was there.
This one.
This one, yeah, this one. You can see. So this the purpose is just a object detection. So it sends some sound signal, and that sound signal is just reflected after that from any object, and that is received by the same sensor. So during this, we calculate the duration of this period. So after sending the signal and after receiving the return back. So what is the duration of this time? And based on that, we calculate the distance. How much actually object is closer to the sensor. So that actually the purpose. So there are many things are actually many devices. So like this driverless car, if you remember this term, so driverless car. So how that actually can detect the object based on that it takes the decision. Okay, it just turn on the brake like this, so it will stop. Our car will be stopped like. Okay, so many
Yes, sir. Why
applications are
there is
there for the sensor.
Where is this document
there
available,
is
sir?
You can just
Vishalji
Google it.
on
Google
Google,
it,
na?
I
Just
think.
googled it. Yeah.
Okay, sir. Thank you. Thank you.
So just write a ultrasonic sensor working like this. You can
Okay,
type
thank you.
and you
Thank
will
you.
see.
So here are the
Okay.
specs.
So this some specs are given here. So what are the like a signal things, operating range, 2 centimeter to 400 centimeter it can detect. Okay, so this is just a specification of the sensor, so that comes on the market. You can select what specification you require. So but here we are just discussing the how actually we can work on that, so you can understand that how you can use this.
So these are the pin you were talking
This is the
about, sir.
yes, yes, yes. This is the same model I'm using.
Yes, sir.
So VCC, you can see first pin is the VCC for power. Second and third pin is trigger and echo. Fourth pin is the G and E as ground. So this trigger is the purpose is also written here. So this triggering input pin, 10 microsecond TTL. Okay, so time to live pulse. And after echo is received the proportional to distance output pin. So we will discuss that how we can write the code for this. Okay. So I hope basic idea is clear to use this sensor. This is just a object
Yes, yes,
detection.
yeah,
How
yeah.
much distance object is there?
Yes, sir.
Okay.
Sir, the sensor VCC
Hmm.
and ground is always connected. Okay, and
Hmm.
trigger and echo. So when will these two function, sir? These two pins.
So that we will decide in our coding. So we will generate some that signal for the trigger pin, and after receiving the signal on the trigger pin, it will generate the signal. Okay, and that signal will be received after reflecting. So that will be received by the echo. So we will check if we are getting any that signal on the echo pin, then we will receive that. Okay, so we will just calculate the time duration of this cycle. Okay, sending the signal and receiving the signal. What is the time duration for that? And based on that, we will calculate the distance. Okay, so we know the sound that sound signal speed. Okay, so what is the generally sound signal speed we have, and we will use that, and based on that, we will calculate the distance in the centimeter. Okay, and we will show you that we will also print this distance. Okay, based on the sensor information. Okay, shall we move?
Yes, sir.
My both screen is visible or one screen is visible?
One screen. Both are visible, sir. Both are visible. Now the mobile has turned off, sir. I mean, it's not from the. It's not.
Okay.
Yeah.
Okay. Okay. So I have, this idea is clear. Then let's move to this. Okay. So here now the main purpose is this two document. Now we identified that what is the corresponding port. Okay, so port pin we are using port A. Okay, and port A pin 5, port A pin 6. So this is for trigger and echo, and port A pin 7. So, this PA. Okay, we have to check that for D7. What is the pin? D7. D7. Okay, P8. Okay, so PA8. So that we have to. D7 is referring to PA port A pin number 8. So this is the pin, and we will be required one timer. Okay, timer to find out the duration of the signal. Okay, so after sending the signal and after then receiving the signal. So what's the duration in between? So we will use the timer for that. And so these are the things we need here. Okay. So now we will configure this, all this basic information in our code. So we require this std in, and we will also use the print statement. We will just debug that how much distance we are getting from the sensor to object. So that we will also use the print statement. So I am writing include this has include, and after that stdio.h. Okay, so this is for print statement only I have taken. So now in the main function I'll write the code. So before that main function we will write the setup and all this loop part, and before that we have to assign some basic uh, that address. Okay, so basic address we need to assign. So what are the basic address we have? In the documentation we will understand that what is the base address for that port A. Okay, so this is the reference manual, and inside this we can see system and memory overview. So system and memory overview, so we will see what is the starting address of, you can see GPIO A. Okay, so this is general purpose input output A. Okay, so A means port A. And what is the starting address of this is 4800 and 410. So this is the base address for this GPIO A port. And after that, we will identify the address for each pin. We can identify the address for each pin because each pin actually contains some registers. Okay, so each pin
Sir,
contains the,
3 minutes.
yes. Hmm.
Your screen is not visible on the YouTube live channel.
Hmm. Okay, I have already pin. One second. It is not visible. One second. Can you see now?
Yes, sir. It's visible.
Okay. Okay. So, okay, thanks. 1 second. Let me close YouTube. Okay, so this documentation, what I'm sharing here, so this contain all the memory linking, all these things. So you can see here what port actually base address is started from. So this is the starting address, or we can see that this is the base address for port A. Okay, and so only we are only using this port A, so we will only just require this address. We are not using any another port. So for GPIO, basically we required this address. We also required the RCC. Okay, so that clock. So that clock is actually comes here. You can see this pin AHP1, and this is the address for RCC. Because if you want to use any port or any that timer, so we have to enable the that clock for that. So because of that, we require this base address for RCC. So RCC base address is this one, 4002100 triple zero, sorry. And another is we required one timer. So the timer we can use. So let me we can use. Uh, so we have one cycle. Here also we have this. Team two we have one. This team eight. Yeah, so we will use basically this timer, so that it have the base address is 4 and after that all 0. So this is the base address, and we need some configuration for all these things. So GPIO we need configuration, and that RCC we need configuration, and timer we need some basic configuration. So that things we require. So because of that, this base address we require. Okay. So here we will define all the base address. So that like we can define like this. So define, you can, we will use the macro. Okay, so that we have already seen in the see. And how we actually write, so these things we are just defining the things as a globally, and we will use all these things in our program. So that means instead of that maintaining the address, we will just give some naming actually. Okay, naming convention. So we will give some naming which we can understand, so that we can use like as a GPIO, GPIO A. Okay, so that is general purpose input and base. Okay, so because this is a base address. And what is the starting address of this is? So that is 0x, and this is 4 8, then all 0. Okay, so like this is 1 2 3 4 5 6. Okay, so this is the base address for GPIO base pin. Similarly, we will write for uh, another is RCC base. So what is the base address for RCC? So RCC base we have, and after that we will also write the base address for timer. That is timer base. So here we are using the timer 2. So TIM2. So this is the base address we have written. After that, we will access the add that registers of all these things. Okay, so first we will discuss about the GPIO,
Sir,
and
here
before that,
Here for RCC and timer 2, the base address will be same, sir.
No, sorry. This is 0. Okay. So in the
For
documentation,
RCC also.
you can see documentation. This timer is this 4710. Okay, and that RCC was this one. Okay, 400 and 21000. So that we have taken. Yeah. Okay. Okay, so that is also not correct. So we have to correct 480 and 21. 400 and 2100. Yeah, this is the base address. And after that, we will also find out the RCC, actually RCC register address for this, because we need to enable the RCC. So we will define like this. So define we are defining here that RCC register. Okay, so that clock register. Okay, so define, and we are giving the name RCC underscore, and that. Okay, so let me explain here in this documentation. RCC clock. Okay, so this you can see there is option reset and clock control. Okay, so this RCC. Inside this, when we open this, so there is one option RCC registers, and when we expand this, so now we have the registers here. So this is RCC registers. So we need to identify the registers for where is our actually GPIO connected. So GPIO connected is AHP2. Okay, so AHP2, we need to identify that where is the AHB2 we have. So AHB2 you can see peri enable. So that is one enable register. So AHB2 can figure out here. Peripheral reset registers is not there. Enabling PP1 AHB2 is also not there. And okay, so HB3, HB, not this one. AHB2 peripheral clock enable registers. When we click this, you can see this is the pin GPIO-A. Okay, so this register that offset value is 4C. So that means this offset value will be added into the base address to getting the address of this register. Okay, AHB2 peripheral clock enable register. So that means on this bus, AHB2 bus, we want to enable the clock for registers, and this is the port name. Okay, so GPIO port A. So that means this is a 32-bit register. If we set this first bit as a 1, so that means clock is will be enabled to this registers. Okay, port A, all pins. So that our clock will be enabled for this. So you can see 0 means disable, 1 means enable. So this is our task here. So first thing, we need to identify the address, main address of this register. Okay, so this is for the port. So that we will add 4C in our base address. So that actually we will perform here. So we can write AHB2, and we want to enable this, and that means enable. Okay, so we can write enable register. So we can define here. So how we can write this, or we can directly assign. If you can want to save tag, so that means you can define that 4C. If you add in this 4C, so that thing is the first thing, HB2 clock, and same way you will identify the address for clock. So that is clock is comes on that is memory mapping, and again you can see clock comes on RCC AHB1. Okay, so AHB1 Mm, HB1. Okay. So HB1 RCC we have to enable here, so that we will identify the register for that. So that register is basically AHP1 RCC. That no, RCC is this one, but we need to identify the timer. Actually, we need to enable the timer. The time two is this APB1. Okay, so APB1 bus we need to enable the timer. So APB1, APB1. Yeah, this is the enable. Just see the in the same way. So APB1 peripheral clock enable register one. Okay, so this one. So inside this, you can see this is the offset value. So that means in the RCC register base address, we will add this. Okay, so 58. And inside this, this is the first pin we need to set one to enable this RCC clock. So this is required here. So what will be the base address for RCC base is this one. And inside this we will add 58, so 58 will written like this, and we can write like APV1, APV1, and this is the RCC. So now this is the address to enable RCC. Now next is GPIO. Okay, so how we want to use our GPIO pin? So we have a GPIO pin like pin 5, 6, and that 8 port 8 pin. This we want to use. How we want to use that pin? So that means we need the
Sir,
base address for each register. Yes.
sir, how you are determining, sir, that is APB1 enable register or APB2 enable register? Because
So
both
this
are
is just
RCC.
a this is just a naming actually. Okay, you can give any name. Because instead of using this address in our code, we will use only this term. So this is just indicating that one space is added.
Sir, both are RCC, na, sir, registers, na?
So both are actually related to the clock. Actually, we are using GPIO. This is a one peripheral. Okay, this timer is also one peripheral in our microcontroller. And if we want to use these peripheral, we have to enable the clock frequency for this. Okay, we have to
But that
enable
means
the clock.
two peripherals require two clocks, na, individual clocks.
Individual clock in our microcontroller. So we have to enable the clock for this actually. And both this GPIO is actually connected on this AHB2 bus. Okay, so this is one. This is called as a bus. Timer 2 is connected on this APV1 bus. So both have actually different bus. So because of that, we have to enable the clock for both separately. Okay, so we are identified the address of the to enable this clock frequency, and this is the address for both. And after that, at this address we have 32 bit, and we will set our first bit as a 1 to enable this. Okay, so at this address we will set first bit as a 1, so that we will use with the help of that bit of that bitwise operations. So that we will do. Okay, so here first thing is we are just defining. So here in this code, actually, I am using the structure also. So in this Week-8, what is discussed actually, how we actually write a good code for the our project. Okay. So generally, this is the a normal or very commonly used convention. So define your address like this with the help of some macro and use this macro in your code. And if you want to change the address of some place, so just change inside the macro, so that will be reflected in your complete code. So this is just a common practice. So now this is two peripheral we need to enable clock, so that because of that we have identified the address for the register. Okay. Now next is port. Actually, port address we want to use. So that means GPIOA. So one pin we need to use as a input pin. another two pin we have to use as a output pin. So that we have also this, we have to configure this setting also. Okay. So for this, okay, so let's move to the GPIO register. So what are the GPIO register we will use here? So that is clock and general purpose. You can see general purpose option here in GPIO register. So GPIO first register, actually this one. Okay. So this register actually set the mode register. So which mode actually we want to use that pin. So if we are using any pin, if we are using pin number 5, so which mode actually we want to use that? Input mode, output mode, the second one, output mode, or any this alternate function mode, analog mode. These are the four options we have. But our purpose is here only to use as a input and output. Okay. So the pin number 5 we will use as a output to a sensor. Okay. Pin number 6 we will receive some information from the sensor, so that we will use as a input mode. So to set our pin into a input or output mode, we have to set some value in this register. So we have to set, for you can see for pin number A. So we have to set these two bits. So if we set this 2 bits 00, so that this pin actually port A pin number 0 will work as a input pin. If we change these 2 bits into 01, so then this pin will work as a output pin. So in this way, we can set our pin configuration. Okay, so that we will identify the base address for each pin first. So that is not base address here, actually for this address. If we identify this address, here from we can set our each pin. So pin number 5. So pin number 5 is this one. We will set as a output pin. So that means 01. So this 2 bits we will set our 01. Pin number 6 we will set 00 in as a output input pin, 00 input pin. Uh, Pin number 8. Okay, so we will use as a output pin. So output pin for 01 for LED. So in this register we need to set this information. Okay, so this is the base address we require. So GPIO mode register, we call this GPIO a mode register. So what is the address of this? We will write here. So that means GPIO. Now we are configuring the GPIO settings. So we will write like GPIO. We are not configuring, we are only just setting the address first. So head and define, and we will give the naming like this GPIOA. Okay, so GPIOA, and this is for mode address. So mode and enable register. So that mode register. And what will be the address? Because the first address, okay, so base address for the CPIO is this one. Okay, and this address itself a first register address, that is actually mode address, mode register. So we will use the same addressing here. Okay, so this become a address of first register, but we need more register. So this is just a setting the mode. After that, we also required another register. So that is actually input data register and output data register. So that you can see GPIO port output type register. So not this output speed register, not this, and this one. Because we are using only the pin as an input pin or output pin. So we need to set some input data or output data on these registers. If you want to send some output data, we will set these pin as a high or low. Okay. So if you want to send high signal on some pin as a output, so we will set that pin number as a high in this register. GPIO port input data register. So this is input and this is the output. Sorry. So to send the output signal, we will set signal here, value here. Okay. And to receive some input, that input will save in this register on the pin number. So this is reflecting the pin actually 0, 1, 2, 3, all this pin. So what is the GPIO output data register offset is 14. Okay, and input data register is 10. So this is the address for input and output register. So output is 14. So we will write
So
here.
we have to use the offset value also, sir, for this. The ending digit should be
Ha.
offset value.
Yes, yes, yes. So GPIO A and that is output register. So we get that ODR output data registers, and that is actually 14 offset. We will add in the base address 14. And next is the input register. So that input register is also required. So IDR, and that is 10. Okay. So now this is the address we got for the GPIO. Okay. This is the configuration required for GPIO on these address. So configuration we will done inside the main function as setup. Now next address is the timer. Okay. So timer things we need to set some address. So we'll use like has define and team2. Okay, now here we need some like four setting, actually four register we need to set here, so that if you check the timer registers in this document. So general purpose, and let me check timer. So power reset clock lower general purpose PIOA peripheral state message so this is timers. So you can see here this 929 option. So team one, team two. So we are using team two. So that is the things, and this is the register for team. Okay. In this registers, we required actually four register to set. One is actually CR1, and so these things CR1. There are multiple registers we have. Total 10 registers we have. So this, yeah, this is the first registers. We need to set some information in this, and this information actually control register. So this means tim X. Okay, so which timer actually we are using? Timer 2, and CR1 is a control register. So how we control these registers? So enabling and disabling the timer and setting various control actually bits. So that is this information is required to set this timer. Okay. So these are the option we have. So this is a one time of type configuration. If you want to use some timer, so we have to set actually okay, we have to configure that timer for some specific option. So that we will discuss. So another this is the first timer. Base address is 0. So this we are required CR1, and another timer is the next timer. So CR2, that is also required. So CR2 purpose is stay the CR2, and this is the option, and the purpose is just a actually increment with each timer tick, providing a basic measure time intervals actually. Okay, so that means what is the interval for the each tick of the timer, so that we have to set in this register. And next is just a on this one, this is that is this basically next one is this GR. So that another is, let me check. Port control register and set status register event generator capture compare move register register. Okay, some pre-scalar value we need to set in this. So that we will check which actually register will contain the pre-scalar value. And some other one setting is auto rotate register. So that setting we also require to set. So basically four setting we required in this register. So that we have this information. So let me check. So first is simply like this. Tempo.
Sir, here, sir, sir, here GPIO base register and also GPIOA mode enable register. Both have same address, sir. Is
Ha
there any
ha ha.
difference, sir?
So that means the first register started with the same base register. So each register takes 4 byte. Okay, so 4 byte means 32 bit. So first register start with the base register. After that, second register will start after the 4 byte. So that means add 4 into the first base address. So second register will be start from the like 48000004. Last bit will be 4. Then after 4 byte, next register will start. So each 4 byte register will be changed actually in this way. So first register actually starting address is the base address itself. So 32 bit will be start from the base address. Then the second register will come. Okay, so GPIO mode register itself is first register. So because of that, it is taking the base address directly. So CR1, so this CR1 actually required this base address because this is the first register. And next CR2 is just a next register. So that will not CR2 actually required it. So for let me see, 6 times Team X. Fourteen. Not this. That address is actually 24. So 24 is 18 and 15. Let's see. This address is required. Okay, so Team X and this is Team X CNT. Okay, so timer actually we have more bit required. So not only 32, we have more bit required. So second information we require from this address CNT. And this we need to set some bit interval basically. Okay, so how much bit interval is required for this timer? So that we will use offset this. So not so we have any CNT. And this is 24. And third configuration on required. So that is actually called is TS. And that is the next address after this. 24, this one. Okay, so this PSC. So this address is required. So that is 28. And so we'll write it 28. So this is just like a configuration. So don't worry about this. If you will read the each part of the documentation, you will understand that what is the purpose of that. So we are not discussing everything. So next, what are the main requirement is there that we are only writing it. Okay. So next is reload register. So that is ARR, and that address is actually 2C. 2C, this one, auto relate register. Okay, so ARR is the 2C. So that we will add here 2C. So this is the timer registers we have defined. So timer config for the timer configuration, and this is the things. And what pin we are using actually. So that pin we can also define. So that has define, and for trigger pin. Okay, so TRIG, we can give the name for that pin. So TRIG pin, and that pin number we will use as a pin number port a 5 pin number 5. Okay, and another pin we are using as a echo pin. So that is echo pin, that is pin number 6, and another pin we will use as a LED pin. So that pin we are using PA8. Okay, so PA8 8. So here we have defined this naming for the addresses or a pin name. So directly we will use this term in our code. So that is LED. Okay, so that is LED. Okay, so now this is just a address configuration. After that, we will write our main function, or that we will set the configuration things. So one function we will write as a like init function. So that init function void init. Okay, and you can give any name like init sensor or project like this. Okay, so anything. So this is just empty. So init means initializer. So what value we need to set here? So we got the address. So that means we need to enable this RCC first. We need to enable this mode registers for pin 5 as a that output pin 6 as a input pin 8 as a output pin. So we will define the mode, and we will use this GPIO A ODR and IDR. This we will use inside our code to read and write out data. And we need to configure this CR1, CR, this all this value also to set this timer, interval, everything. So that is also required, and this part is only to just naming convention. So for initialization, this part should be done. So here first for the enabling that pin RCC, so we will use this register. So we want to set our pin first bit, okay, first bit of this register as a high bit. Okay, so we have already seen the operation or bitwise or operator. So bitwise or operator actually perform this task, and we can write like as a 1 and 0 setting. Okay, so this is the setting as a, so that means we are taking this one value. So this is a integer one value. So what is the corresponding binary is 00001 like this. Okay, so this is the corresponding binary for this one. And we are not shifting any bit. Okay, we are not shifting left. We are not left shifting any bit. So this means, so the on the right hand side only one is there, and the remaining all bits are actually 0, and we are performing OR operation on this. So this will work like this. So we have some basic of value maybe in the register, so that like 110101 like this. Okay, so suppose remaining value are also there. So this is the zeroth bit, 1 2 3 4 5 like this. Okay, all remaining 32 till 31. Our goal is to set this bit as a higher bit, okay, at to 1. So what we will do, we will perform OR operation with this 1. Okay, so now we are performing the what is the value in the registers and this value 1. Okay, and we will perform OR operation with this. So OR operation takes, if any bit is high, output will be high. Okay, so that will generate a high bit for this bit, and remaining bit will remain as it is. Okay, so one, this zero zero will become zero, this one zero will become one. So all bit will come through with the registers as it is. So that will remain as it is. So now this first bit is set, okay, to high. So this will be confirmed as it our clock is enabled for this port. So this is the first operation, and next is second this. Okay, so this RCC APB. Same things we will do, because here also we need to set only the first bit to enable. So same things we will write for this also. So now our clocks are enabled. Okay, for GPIO as well as the timer. Oh, sorry, yes, timer. Okay, so our clocks are enabled by this data update. So this is the things. Now next is set our GPIO pin to input and output. Okay, in this way. So next operation is GPIO mode register setting. Okay, so GPIO mode register is this one, and we will read this address. And first thing, okay, so for pin number, as I may show you that each bit require 2 bits to set. For as a input data 00, output data 01, we need to set on that. So that means first bit we need to set 0 and 1 bit, okay, for first pin. Second pin we require 2 and third, second and third pin index, okay, 2 index and third index pin need to set. For third pin we need to set 4 and 5 in this way. So that means we can do the calculation like this, because each pin is taking 2 bits, so we can multiply the pin number on to set this. Before setting 2 bits, we need to clear them first. Okay, so that means we need to clear maybe what is the previous settings there. So that means both 2 bits need to be cleared to 0 first. Okay, so how we can clear this? So that we can use the AND operator, AND bitwise operator. That AND bitwise operator, okay. And to clear this, okay. So how we clear this? So that operation is actually 2 bit. How we can clear 2 bit? So we will use 3, and we will shift that 3 means 1 1 in the binary. Okay, so 1 1 in the binary, and we will shift that pin to a 2 into. So that means 2 into, what is the pin? Trigger pin. Okay, so trigger pin we need to say reset first. So we are resetting first. Okay. Error, syntax error, to focus. So that is GPIO. Okay, for setting we need to also negate this. This is some error is there, syntax error. Okay, we will check this. So after clearing the bit, we will set our required bit to make this bit as a output bit. So how to make this as a output bit? So we will use the OR operator now. And to set this only, we need to place 1, because set as a output bit we require 0 1. Okay, so we will use 1 here. One, yeah, this is the setting. So that means we are clearing first both bit as a 0. After that, we are setting our bit to a 0 1. So this one is indicating to one, and we will shift this bit into the required position, which pin is actually required by multiplying by 2. And in this way, this bit will be set. So this is for pin number 5. Okay, so this is for pin number 5. So pin number 5. Same thing we will do for, so this is for pin number 5 as a output. Pin number 8 we also require as a output. So same thing we will do with this pin number 8. So that is LED pin. Only change this. Okay. And another is pin number 6 is a input pin. So that is required as an input pin. So we just write it. So here this is echo pin. So both should be 0. So to setting the 0, we need to perform this AND operator like it. Pin number 8, this pin number 6. Okay, so this is now a configuration for GPIO port. So we have set the mode. I think some there. What's next? Let me see. Let's. Check later. Okay, so this is the pin configuration for GPIO mode register. After that, we will set. Okay, so this is the GPIO configuration. After that, we will set our that timer configuration. So that is actually timer. This. So we need to set our this pre-scaler actually things. Scalar we will set like 80. So this is actually a set pre-scaler to 80. We are assuming that we are using 80 megahertz clock for 1 microsecond tick. Okay. So because timer also use this clock, and clock have the very high frequency. So maybe 80 megahertz. So that we are assuming here. So because of that we are scaling. So 80 megahertz clock will be considered as a 1 microsecond tick. Okay. So we are just scaling this value here. And another is for enabling the timer. So we will use the CR1 register so that this one. So that is directly or web operator. So this will work as enabling. So and another is auto reload to maximum. So that is ARR. So that we will set to maximum as we have to set as and this is all value actually one. So FFFF. So all 32 bits we are setting to as a highest. So that is the one configuration. And another timer which is the required to this is count. So we will use this value as a counter. So later in the code. So this is the configuration required for the timer. Okay, so now the init part is completed, and we will for checking the distance. Okay, we will write another function. This is a little bit. Yeah. So I'm returning int distance. So distance measure. Now we will calculate the distance from the sensor. So here we will first thing send we will send a signal to the trigger. Okay, and 10 microsecond signal we will send. For how we will send this 10 microsecond signal. So we will just make that output data register bit high. After that, we will make a delay for 10 microsecond. So that time, this our bit will remain high. After that, we will change our bit to low. So that means during that time, our output will be high and our output signal will be set for that duration. So that pin number 5 basically. Okay, so this pin number 5 on this registers, that output data register. So which we are using ODR for this pin number 5 for this ODR register. So we will make the bit high as a high pulse. Okay, and we will keep this bit as a high for 10 microsecond. After that, we will make this as a low. So this will become a 10 microsecond second trigger pulse. So that we will do. So GPIO ODR, GPIO ODR. Okay, we need to set this to high. So for sending the data to the high, so we will just use a OR operator and equal to and one bit on which we pin our the trigger pin. That is this trigger pin. Okay. And for 10 seconds, we will send this. So we will use some delay here. So delay function is not created. So I'm just writing here, but we will create a delay function for that also. And after that, we will make this as a 0. Oh. So, and this we will use here and symbol and negate this. This will become a 0. So this is the function. And after that, yeah, someone is asking something. Okay. So this is now we are sending the signal. Okay. So sending the signal to the sensor, and sensor will generate a that sound signal after receiving this. And after that, after sending this signal, we will wait to receive the input. Okay, so how we will just wait? So we will just use first we will set the timeout also. Okay, so maybe sometimes if there is no object at the front of sensor to the large distance, so in that case our sound signal will be sent, but maybe it will take too much time to return back. So in that case, we will just use some timer that like timeout things. So I'm taking like int timeout one variable, and we are setting this value as a 1 lakh. Okay. So this is the interval we have as a timeout things. After that, we will check uh, the input signal, how we are receiving the input signal. Okay. So for that, we will check our IDR registers. Okay, input data registers. So that we will use as a while condition, and inside the while condition, we are making as a condition if while if our IDR of that input data register is not high, okay, and our timeout is not completed. So that condition we will check inside the while condition, and we will repeat this, okay, because we have to wait to receive the signal. We cannot just check one time condition. We have to iterate this, and we have to wait for the receiving signal at the input data register. So that we are running the loop here. So inside this condition, we are checking this. So GPIA input data register. So that is this one IDR. For this data registers, if this is we are reading the value, okay. So if this is not high, actually, and and what is the value of that one step echo pin? Echo pin. That means if this is this register value and this pin value is not high, or second condition we will take as a AND operator and logic AND operator and timeout. What timeout we are taking? Okay, so this we will repeatedly perform this, and inside this we will reduce our timer. So time out minus minus. Some bracket is missing. I think 1, 2, 3, and then 10. Okay. Okay, so I think some register indication is incorrect. So we will correct this later. So this loop we are running. We are waiting for the input signal and running the timer. Timeout these things. Okay, and we will check for this duration. And after that, for this condition, if we have not received, okay, we have not received any signals, we will check if our timer is now zero, the timeout value becomes zero. That means we have not received signal, and we will return zero. We return zero directly from here. Otherwise, then next thing is now we will calculate the count that duration of the pulse. If we are receiving the okay, if we have received the echo, okay, then we will calculate the duration of that. So that we will take one variable. So time that time to count. So that we have already used. So time two and CNT. So that we have already defined equal to zero. We are resetting our timer. So this is actually a timer. Okay. So now we will check our condition. Now some calculation is required here, so we will validate that. So here limit of our sensor is 400. Okay, so that condition we also need to check. So we will just check this while. So how much duration actually our echo signal is remain high? Okay, so that we are calculating here. So GPIO IDR and same thing GPIO IDR and simple inside this one. How we open. Click open. So that duration. And another condition is so for the large distance calculation. So that we can write here. Otherwise, if we have the limited closed area, so no required also. That is also fine. And this in this condition, we will run this loop. And for this, okay, so counter is there. Hmm. And next is okay. Finally, we will calculate the duration, pulse duration with the time count. So now our time count is actually zero. So this is started when we are running this while loop. Okay, and no, takes. one value actually time count value. So this time count we are calculating, and because here we are calculating the interval of the time, and after that we have to also calculate the distance. So for 400 centimeter distance, our time interval should be approx 60,000. So less than 60,000. So we are taking the 60,000 as a time count value. Okay. So this is actually equivalent to more than 400. So we are getting this type value. That means our time distance is become more than 400 centimeter. We are making this condition and running this loop. So our time counter will also run. And after running this loop, we will set our that pulse duration. So pulse duration equal to on the time. And now we will calculate the distance so that distance equal to. So we know that the sound speed is approx 34,300 centimeter per second. So based on that, we will, and our signal is going one side, and after the reflecting from the object, then returning back. So this is the two-dimensional thing. So we will also divide by two to calculate the distance in signal. So that is first pulse duration into our speed 53 and divided by 2 into 1000. This is one calculation for distance calculation, and we will return this distance as a centimeter distance. Return. So this is the distance measure function part. After that, the next thing is the main function. So inside main function, first we will init sensor. This we will call this function. So that is the first thing. Next thing, also everything is the return. Next thing is the distance. We will just int equal call this function distance measure. And, and this will be run as a while inside the while loop, because continuously we will calculate the distance. And after getting the distance, we will check. We can take some threshold. So if our dist distance suppose is less than 30 centimeter, so we will make our LED pin high. So that is actually GPIO operator. So GPIO ODR. We will make this as a high. Pin. Otherwise, we will make as a else. And no. Okay. And here we will perform some delay. Okay, so that delay we can pass through the for loop. So like for and 0. 10 left. We are passing some delay to checking the distance and I plus plus. This is just a empty loop for the delay. And okay, so now this part is done. Main function. Okay, so one delay function we also required because to we have used this delay function. So that is like a void delay date take some integer value as a count. Let's see and count, and that we will use the timer here. So time to see why. This is the time delay time. Okay, so we are using here. So this code is almost done. Okay, let me check. So how we will just build this? So I have written this completely and I'm not using any print statement. So select the project and click on the build project. Okay, so let's see how many errors are coming. So what type of errors are coming? L value required as left operand of assignment line number 33.
Sir, I
So
think we need to typecast it to int star.
okay, this is the address and first address we have to type first. Yeah. So that typecasting we have to done. Okay, so what type we are taking? So let's print.
Unsigned int.
So we are using std int here, so we can write like u int. So this is inside int int and
Maybe we could include a star also, sir. Unsigned 32 star.
like this, no? Pointer is a pointer. How we have to work as a pointer.
Yes.
Okay, so this is so Also, I think we also require this. Think to have all of it I could be required. Line 33, this one.
Semicolon is not needed to after hash data.
Yeah. Where? This one. This is not. Okay, so anywhere is not needed. Yeah. Like, one second. Yeah. Hello.
Yes, sir. Yes.
Yeah, I've approved, sir. This one. Wiring. This time is less than CNT, CNT, and CPR. Okay, so we have also used the CNT to type.
there is one greater than symbol after that count. It's syntax error.
And delay. Okay, now this is done. And and will be required as left operand of assignment. Along this is a pointer. And any other area from anything wrong in this RCC not equal to we have said
Maybe the same typecasting problem. I think they are not typecasted. I think.
RCC HB2 oh it is not done yet. GPU idea and is still found. And declare active and active only once for each function to improve. Mm, loop is wrong. So now all error are removed and let's run this on the board. So we have to run this. So first time it is asking if we are not using any debugging, so we will directly run this. I think no settings required. And I think my meeting is disconnect. So let me check this. So I'm opening my. So still it is not completely working. So I'm opening my laptop camera. So I think still some error is there. So this is not detecting anything. Okay, so I hope some idea you have given, but you have to debug still. I think some issue is there in the code. So what is the code? Let's see. Code is working fine, but yeah, but some I think logical error is there, and some place maybe some addressing or something. So that we have to figure out that with the debugging process. So I hope this is the idea. We have already discussed this type of program in the initial session. So we have defined all the base address for the GPIO timer. Okay, and after that we have set the pin. So in this way, generally we write the any project if we are creating any project. So this is the commonly writing convention. Okay, so first we define the address with the help of this naming. Then we declare the function for each task separately. So that is the modular approach. So that actually divide the big code into a smaller part of the code, so which is actually easy to understandable as well as the maintainable. We can later maintain also. So here delay we have create the separate function, and initialization we have created the separate function. So this part is actually only initializing the things, and this is the distance measuring. So this is the main part of the sensor, sending the signal and receiving the signal. After that, getting the time interval using the timer count, and after that distance calculation, and then we are returning distance. Okay. So after that, in the main function, we are simply calling the init sensor, and after that, inside the loop, we are just we are calling this function distance measure, and this function should return the distance from the sensor, and that is if distance is less than equal to 30. Okay, so GPIO this we will turn on our LED, otherwise turn off of the LED. So maybe there is some mistake. So I have already done this before. So this is actually the previous code. Let me check that you. So this is test two. So this was the approx same code. So you can see here we have also used the debug things. So we are I'm also printing the distance so that we can do with the help of debugger. So I'm running this code. Later we will correct our previous code also. So what is the mistake basically? So I'm running this code ultrasonic test 2 build project. So this was working fine. Okay. And they done this. So one is on the board. So I hope my you can see this code is now um, uploading on the board. This red light is blinking. So after that, so on that actually I think pin was different. So let me change the pin in the code one second. So pin was used as a 9, but I'm using 8. So again, you have to build this and run this. Okay. So now you can see this is uploading on the board. And this is uploaded. So you can see this when I am just putting my hand at the front of sensor. Now this LED is actually turn on. Okay, and if I remove this, some wire is also coming. If I removed everything from the at the front of sensor, so LED is turned off. Okay, so again you can see if I am just putting my hand at the front of this, so LED is now turned on. So these things we can also see with the help of debugger. So I have actually used this print statement also, and I have also set some startup code that will actually return our output. This print statement on our debugger code. So that how we can do this, how we can check the distance. So let's show you that we will run this code as a debugger. Okay, so we will just again run and debug as this. So now you can see this code is stopped at some particular main function first line. Okay. After that, we will open our this SWV ITM data console. So here our output will come. Okay. So what actually data will print? That data will come here. So let's run step by step. So I am just entering into the step one. Okay. So inside the while loop. So initialization will done. That is now first call. Next is now print statement, and I have just print some hello world message. So that will come. You can see in the output console. You can see this is coming here. So next, if I just go one step ahead, so you can see this is the distance. I'm printing the distance now. So once again, next step. So that is you can see 740. This is coming. Now this is a big loop actually running, so I have to remove this loop to check the next distance because otherwise this will run 10 lakh time. Okay, so again I am debugging and I am making this as a comment. So this is now become comment. So again I am debugging this. First we have to build and debug. Okay, so step by step again. So let's see. You can see hello. Okay, so that is 32. Now 2057. This value is coming. So this is calculating because their object is very high distance. Next iteration, I am just putting my hand at the front of this, and I'm running the cycle again. Okay, so iteration again. So you can see now distance. You can see 8. This distance is now 8. Okay, I am just moving my hand a little bit far from this. So let's run again. Now you can see 21. So this is calculating in the second. If I move more at the at the front, so it will calculate 38. Okay, so in this way, this is calculating the distance, how much far object is there. Okay, so if you just move the object at the front of this, just change the distance, that will actually reflect here also in the code. So this is the debugging process. We can check what output we are getting on the serial wire. Okay, so that is just a configuration. So how we can set up this configuration. So we can use any print statement in our code, and after that, to enable this configuration, we have to go into the configuration setting. So debug and debug configuration setting. Okay. Inside this, inside the debugger, we have to enable this SWD. Okay, SWD. We have to select this, and also we have to serial wire viewer. So that we have to enable this. By default, this is not enabled. We have to enable this. Okay, and we will use the setting which is already filled by default. And first we have to enable this. This is the first step. And next second step is after enabling this, we require some code actually. So that is we will insert inside the system call. So inside the file our folder there is one after this main.c. Below this we have the syscalls.c. When we click on this, so this file actually opens. Inside these files, we have added one code. So that code is from this one. Okay, so from this one to this part. This actually, okay. Um, Not this, till this, only this function. So this code actually is just a startup, setup code. And when we perform any print statement, actually, so this will not be print in our that output console. So we have changed our print setting by this code actually. So when we are calling this our printf statement, so by default internally this write function actually called this write is this one. Okay, so this write function is called. Inside this write function, this by default this put io put care function is called, and that actually print the data which we are passing through the printf statement. But we have changed this to our function. We have just added one function itm that send care, and we are passing the same pointer here. So what character actually we are what string we are printing through the printf statement, that we are passing inside the as the send care, this function. So this function actually we have added as a new in this file at the top. Okay, here. So this is just a bypass thing. So this our printf string will not be print in the output console. It will be passed to the that our debugger pin. So that debugger pin it will be passed. So pin number 0 we have set by default to receive that you can see port 0, that pin we will receive as a print string, and that we will enable by this debugger method. So once we start the debugging, so that actually configuration we have to do. So again let me run this. So inside here, we have to go inside this window option, and window option we have this show view option. Show view option, there is one option that SWV. There is one option, yeah, SWV, and inside this we have this option SWV ITM data console. So this one. So that we have to open, and when we will open this, so inside this we have to setting this we have to enable the port the pin number 0. So that means this code is running on our hardware, and inside the hardware print statement so one string is printing into the print by the printf statement. That string will be passed to this pin 0 as inside the debugger. So that pin actually is coming, that data is coming returned back to our IDE from the board, and that data is printing in our IDE, which we are using as a this STM32Cube IDE. Okay, and we are able to check what data is coming, what data is printing by our board actually code. Code is running on the board, but what data is printing by the code. So that we can debug the code like this. So step by step, we can see what data is printing. So you can see 2379 is printed by this statement. So this is executing on the board, but data is coming back to our ID by this line, serial wire. So this is one a debugger process on the microcontroller. So you can use this if you want to check your output on some variable in some place. So this is the one way of the debugging. So this is a very similar code, but we what code we have written today. So maybe that have some mistake. So I'll debug that. It will take some time. So I hope you got some idea. So I think in the next session I'll correct that code. I'll also tell you what was the mistake. Okay, so there are many application actually can be built up of this sensor. Okay, object detection sensor can make anything. So, any query, anyone? Already 8:20 is there. Okay, so we will discuss in the next session the remaining part. I'll discuss the correction of the code. We will check some other experiment. Okay, if there is no query, then shall we close or any query? Okay. Okay, then thanks everyone. Bye.
Thank you.
Thank
Thank
you.
you so much, sir.
Thank you, sir. Sir, like in the previous class, sir,
Hmm.
in C programming, you have provided some notes, no? Uh, so, is there any notes for this
Hmm.
embedded C, sir, available, sir? In C programming, in
This
Meta,
time,
you have
yeah, I remember that we have created some PDF notes for some as a summary for the each week.
yes, yes, sir.
So that we have not created for this one, but maybe coming session we will create that.
And sir, for programming aspects, sir, so what are the materials we should refer, sir? Only the textbook or lecture videos, sir? For
Regarding programming
I am
assignment, you are
also
asking.
programming embedded C programming part, because due to
Hmm.
lack of practice, I am feeling some difficulty in writing the programs. That's why, sir.
No, actually, because of that, most of the live session we are discussing this practical aspect only. So the remaining live session, the other instructor are discussing some practical on the walkthrough simulator. So that is also
Yes,
a one type of coding. So that is just with the help of some that abstract functions. Okay, but today this type of coding is just a hardware level coding.
yes,
So we are not using any middleware or anything abstract things, direct function. We are writing a complete scratch code. So you can just feel that how we can write hardware level code as well as the how we can use the helper function, which actually provided by the controller. So both type of coding we are doing in our live session. So you can start with the basic things. So I think in the initial first two session I have just discussed the hardware level coding for just blinking the LED or just turn on the LED like this. And also use if you can do, you can purchase some basic board and do the practical things on the physical board. Otherwise, you can also do the practice on the walkthrough simulator, but you will not get a feel. Okay, what you will feel on the real hardware. So because of that, this physical lab, in-person lab is also there for this course in the in-campus. So where the at that time the professor or instructor will discuss the physical board actually experiments.
yes, sir. That is Nucleo C031C6.
That is, I think, board on the walkthrough simulator
Yes,
also. So that you can use any series board. So most of the functionality are similar. So maybe some features are changed. So if you are beginner, definitely you can start with any basic board.
sir. I
Later,
also,
according to your need, you can just check your
when
requirements.
running the program, sir, on Walkway Simulator, if I can't
Hmm.
understand any program, is there any solutions are available for that program?
So you can simply use the Google things. If you're writing any code and
Okay,
you're
okay.
getting some any error, you can use the Google. Otherwise, Chat GPT is also there, na?
Yes, yes,
Have you
yes.
used Chat GPT? I think this is very
Yes, yes,
popular. So you can just use the Chat GPT to resolve
yes,
your problem.
yes,
Okay, so utilize that also.
Oh, oh, how
yes.
to use Chat GPT for walkways?
No,
Uh,
not walkme.
Oh,
What you can do, you can just write your code and you can ask your problem also. Okay, so you can
oh,
just put the code and see what is the error in this. So
okay.
that ChatGPT will help. Okay,
Oh,
so you can
okay.
understand your error like this.
yes.
Okay.
Like in
So utilize
Walkway,
that tools also.
like sir, in
Hmm.
Walkway, sir, I am seeing some problems. If I can't understand how to write a program, so in this, that's why feeling very bad.
Otherwise, you can join the live session. Okay, just join the live
Yes, yes,
session. Maybe tomorrow you can join. I think Levin will discuss all the walkthrough problems.
yes, sir, yes, sir. Thank you, sir.
Okay,
Thank
so tomorrow join and ask all doubt.
you. Yes, yes, sir. Thank you, sir.
Okay, bye everyone.
Bye, sir.
Bye.